Imagine boarding a plane. You take your seat next to a total stranger. You strike up a conversation. You discover you were both born on the exact same day, at the same hospital, at the same hour. What were the odds of that actually happening? The real answer is going to surprise you. In February 1979, two 40-year-old men met for the first time. They were identical twins, separated at birth and raised by different families. Neither one knew the other existed. Both families, completely independently, named their son James. Both Jims grew up and married a woman named Linda. Both later divorced, and both remarried a woman named Betty. Both named their first sons James Allen. Researchers studied them for years. This was never a hoax. Twin studies like this reshaped how scientists think about nature versus nurture. The Minnesota study of twins reared apart found twin after twin eerily alike, in ways nobody could explain. In 1974, actor Anthony Hopkins landed a role that required one specific novel. He searched every bookshop in London, nothing. Then, at a train station, he spotted a battered book left on a bench. It was the exact novel he needed. Years later, he met the author, George Pfeiffer, on set. Pfeiffer mentioned he'd lost his own annotated copy years earlier. Hopkins showed him the book from the bench. The margin notes matched. It was the very same copy. Hopkins later called it the strangest moment of his career. September 2009, Bulgaria's national lottery draws 6 numbers: 4, 15, 23, 24, 35, 42. 1 week later, the same lottery draws the same 6 numbers again. The government opened a fraud investigation. They found absolutely nothing wrong. So if none of these are hoaxes or fraud, how is any of this possible? Here's the twist. Each of these stories sounds more impossible than the last, but not one of them breaks a single law of probability. There are over 8 billion people alive right now. Between them, trillions of interactions happen every single day. At that scale, extraordinary coincidences aren't rare accidents. They are mathematically guaranteed to happen to someone. Statisticians Percy Diaconis and Diaconis-Mosteller studied this seriously. Back in 1989, their conclusion echoed the same idea. With enough chances, almost anything can happen. Let's start with the simplest version of this idea. How many people do you need in one room before there's a better than even chance 2 of them share a birthday? Most people guess 180, half of 365. The real answer is 23. Just 23 people in a room, and the odds already favor a match. Push it to 30 people, and the odds climb past 70%. Push it to 50, and you're above 97%. Push it to 70 people, and the odds pass 99.9%. This is called the birthday paradox. It isn't really a paradox, it's just a math illusion. You're not comparing your birthday to everyone else's, one at a time. You're comparing every possible pair of people to each other. With 23 people, that's 253 separate pairs, 253 separate chances for a match. Not just one chance in 365. Now stretch that same idea across the entire planet. Statisticians call this the law of truly large numbers. With a sample size large enough, any outrageous event becomes likely. A 1 in a million chance sounds essentially impossible. But there are 8 billion people on Earth, so a 1 in a million event happens to about 8,000 people every single day. Somewhere right now, someone is living your impossible coincidence too. Multiply that across every kind of coincidence imaginable, and the numbers explode further. In the 1980, mathematician John Littlewood put an actual number on this. He defined a miracle as any event with odds of 1 in a million. Then he estimated how many events a person actually notices in a day. Roughly 1 per second during all your waking hours. That adds up to about 1 million noticeable events every month. Littlewood's conclusion: expect a personal miracle about once a month. Not because you're unusually lucky, because the numbers make it almost unavoidable. Multiply 1 million events a month across 8 billion people, and miracles aren't rare. They're constant. Here's the part almost everyone misses. The question was never, what are the odds this exact thing happens to me? The real question is, what are the odds some coincidence like this happens to someone somewhere? Statisticians call this the multiple endpoints problem. There are millions of possible coincidences that would all feel equally amazing. Same birthday, same name, same flight, same book, same lottery numbers. You only need one of those millions of possibilities to land. And with 8 billion people rolling those dice constantly, one always lands. This isn't just about birthdays and lottery balls. In 1967, psychologist Stanley Milgram ran a famous experiment. He asked strangers in Nebraska to get a letter to one specific man in Boston, only through people they knew personally, one link at a time. The letters arrived in a median of just 6 steps, 6 degrees of separation. In a world of 8 billion people, everyone is far closer than intuition suggests, which makes impossible encounters far easier to stumble into. In the 1950s, psychologist Carl Jung had his own explanation for all this. He called meaningful coincidences synchronicity, connections beyond cause and effect. It's a beautiful idea, but mathematicians have a much simpler one. You don't need any hidden force, just enough people and enough time. None of this means coincidences aren't real or aren't fun. It means our brains are just bad at judging probability. We remember every hit. We forget the millions of quiet near misses. Nobody posts about the stranger who wasn't born on their birthday. So the rare hits feel like fate, when they are actually just arithmetic playing out at scale. Psychologists have a name for it: confirmation bias. We notice every hit and quietly discard every miss. There's a reason our brains latch onto patterns like this. For most of human history, spotting a pattern could save your life. A rustle in the grass, a cloud shaped like a storm. Brains that noticed patterns survived. Brains that shrugged didn't. We inherited that same pattern-hungry brain. It just wasn't built to handle probability at a scale of 8 billion people. That's not a flaw. It's just an old feature running in a very new, very large world. Try this yourself this week. Find any group of 25 or more people, a classroom, an office, a party. Ask everyone their birthday out loud. More often than not, 2 of them will match. So maybe the question isn't, how could this possibly happen? Maybe the real question is, why doesn't it happen even more often? If this kind of thing fascinates you, subscribe. There's a new one of these every week. And a like tells the algorithm to show this to someone else who'd love it too. Thanks for watching. See you in the next one.